All right, so it's 11:31. We're going to get back into it, start walking through how to navigate a notebook and then some Python basics. And a lot of this will be overlap, but let's jump right in. So in the links in the syllabus, you have the link to this notebook documentation, and we have notebooks open. You should be able to see any of the space at and under the area where you opened your notebook, and then be able to modify it right here from your browser window. So I actually have been working in a work directory, and so I'm just navigating by clicking on these paths like you would, and it's pretty intuitive from my point of view. Let me know if that's not the case, and if you're not catching the clicks that I'm doing here. I'm just navigating to a space where I'd like to kind of save some things and work. So I have some information already here for that I'll share with you all later. But I'm going to click on New and New Python 3. So this is going to open up a new notebook. If you would like to start in whatever space you're in with a new folder, you can totally do that from here as well. So you could click on New Folder, and then let's see, you can click in there and even create your new Python 3 notebook from inside there. When you do that, you'll get another tab that opens up with hopefully a cell and a Jupyter, the Jupyter notebook that we want, with a nice navigable interface here. Notice that the documentation is going right along with what we've done so far, and gives you a lot of additional information here that we'll just kind of skim through. At the top, you have a notebook name, and I'm just going to name it Demo here and click on Rename. And then, like it points out here, we have a menu bar, a toolbar, and a code cell. So we are seeing all of those things, hopefully, in your window. Again, stop me anytime I'm going too quickly, or if you just can't seem to get to the space where I am. The menu bar here is going to give you a lot of different options. There are tons of cheat sheets out there that help you remember where to find things, but these are pretty standard menus that we might see in a whole variety of different other applications. So file is just going to be any of the things that do with saving or copying this particular demo file. So this is going to show up in your workspace as demo.python notebook. That's the name that we gave it. This is the file on disk that's running, and this would be the kind of thing that you'd be saving or making a copy. You can save in checkpoint so that you could revert to a previous checkpoint. It'll do this for you automatically every now and then. You have edit here as well. This is going to give you a lot of edit type activities like that you can do with cells to merge them or unmerge them, split them. And sometimes it'll give you some nice keyboard shortcuts here. You have a couple different view options. You can toggle the header and toolbar. You can insert cells from this menu. You can run the cells once they have code in them. We'll talk about what that means to run. You can run one at a time. You can run everything below. You can run all of them. The kernel is really talking about like the active process that's running on your computer that has all of the memory stored and all of that fun stuff. So if things are getting into a locked state or something, you might be using the kernel to clear everything or run everything from a very fresh memory state, essentially. And then help is pretty cool. I always forget about this one, but I like to use a lot of keyboard shortcuts, and I also like to forget a lot of keyboard shortcuts over time. So help will give you some information about those here, which is pretty nice. And also, it'll give you a whole tour of the interface if you want a refresher later. Also, you can install other kernels. When I say kernel, I mean that you can essentially use any other type of language. Not any other type of language, but many other languages you can have kernels installed for here. By default, it's just Python 3. There are also in the toolbar some shortcuts that you can click with your mouse to do a lot of the things that are done in the menus here. Save, add a new cell. We'll just add a new one down there below. You can cut and paste, and that'll tell you where to paste, copy, paste. You can move these cells up and down, so you're not seeing a lot of what's going on here at this point, but I am technically moving the contents of a cell. I can run a cell by clicking here, interrupt a cell that is currently running, restart. It'll give you a pop-up that says, do you really want to do this? And you can choose whether you want to or not. I'm not going to at this point, but you can. And then you can restart the kernel and rerun the whole notebook. There are different types of cells that you might have. So each of these is a code cell. If I click on it, it says code here, but I can change it to markdown as well. And that just means that I can put some pretty font in here. And then I can run that cell by clicking run, and it'll give me some nicely formatted things. Any of these markdown cells have the opportunity to be totally formatted with a whole language just meant for formatting. And there are references all over the place for how to format markdown. Code cells are where we can put our Python code. So here we might have a comment, and we run that and nothing really happens. Comments in Python are not executed when you execute the code. And you didn't catch what I was doing there because my hands just kind of went on autopilot while I was typing. But if I say put some very basic code in here to set a variable to 10, just the number, and then print that variable, I can click run here, or I can use a keyboard shortcut, Shift Enter. That is going to execute the code in here. So the comment's not executed, and the variable then is saved and printed to the output. So output's going to show up below kind of the gray box where your code is running. Jupyter's kind of neat in that you don't always have to do print, but it's only going to do the last one. So if I just did A, it would show me the last version. If I wanted to say print on an earlier one, it would show me two versions of that. So we get printed and the one outputted. Okay, so every time I've been running this again, a couple things have happened. I've been hitting Shift Enter every time to rerun this code cell, and each time it increments the number over here on the left. You may also have noticed that this line here has been changing between blue and green. There are two different modes for each of these different cells. Blue means that it's in command mode, so I can navigate between these different cells by hitting my up and down arrow keys. This is the mode where I might do some moving of these cells up and down. So blue here is command mode. when I click inside here, it turns to green, and that means that I can edit the information inside the cell and be able to run it again. So Shift Enter again increments the number here and executes the code inside, and then if I do Shift Enter, it dumps me into edit mode in the next cell. If I do on Chrome and Mac, Control Enter, it also executes the cell, but it leaves it on this current cell and just dumps me into command mode again. So these are a couple of things that could come in handy as you're navigating your different keyboard shortcuts, but know that they're all equivalent to just clicking run, and that's going to run the code in the cell. You may see different options, or you may accidentally get into a space where you're like, oh, I don't want to see all of this formatted thing. Notice again that here I'm in a markdown cell noted by this little box here. It tells me that information. It's in green, so I can edit it now. I can put just hello here, and it's going to show up in regular text when I run the cell. But if you ever find yourself in that weird space where you're seeing things that don't look like code and don't really look like text, and it's marked down, you can just run the cell and get back to the state where it's just telling you what's going on here. All right. Is everybody able to open a notebook, kind of play around with some of the different things that you can do between a markdown cell and a code cell? These are very basic things, and we'll definitely be talking about a lot of additional items as we go through the introduction to the actual Python, but these are the very basics of how to run a cell and what the different kind of cells are. All right, I am not hearing questions. So I think it could be time to get into some Python basics. All right. A couple of additional things that I don't want to skip over if I'm just checking my notes again here. Let's see, there are some awesome magic things that happen in Jupyter, and you can see a list of all of those if you just, in a code cell, type %magic and then run it with Shift or Control Enter or clicking the Run button. It will give you a pop-up of all of the types of things that you can do with Jupyter Magic. And some of these things are pretty cool. You can time different blocks. You can, and I mean, there's a whole documentation here of things that you can do. Another bit of magic that's not really percent related here is that it will give you some information about a given method. We'll talk a little bit more about some of this. This is getting into the Python thing, but a string in Python has a method replace. If I want to know more about that method, I can type a question mark before or after, run the cell, and again, it will pop up the documentation for what the string replace method provides us. So you can provide it. It gives you all of the information about how to call replace. It gives you some documentation about what it does and what kind of type that thing is that you put a question mark on. There's one other thing that's probably important, especially as you start working with bigger data sets. So I'm gonna just quickly do a demo here to have Python sleep in the background for 15 seconds. If I run this, notice that while this is running for 15 seconds, I get an asterisk over here on the side. It's not a number yet. That means that something's happening in the background, and I can always quit that with the stop button up here. But once it finishes, essentially counting off 15 seconds in the background, it will change to a number and tell you the execution order. So notice as I've come through here, I'm starting to see the execution order of each of these cells, and that's pretty important because the last thing that ran is going to be saved in memory. So I could come down here and still print A and still get 10 because it was saved beforehand. If I moved this up above A, I can still totally do this, and I can still run this cell because A is in memory. And this was run after the point where we set A to a value, so it's still 10. However, if I restart and run all, so that's clearing all the memory and running all of the cells from top to bottom, it's gonna cause some problems for me. It's gonna hopefully give me an error. It's gonna say that name A is not defined. So if we're clearing all the memory and we've like shuffled things around, we're gonna have an issue because A was defined down here. Now that the memory is cleared, the first thing it tries to do is print A, then we have a problem. So I can move this cell back down to make sure it comes after the declaration of A. Try that again, kernel, restart, and clear output or run all is totally fine. Now it should work just fine. It's going to go in the correct execution order where it defines A as 1. The next one that runs is 2, straight down the list, and here A has been defined. So remember, asterisk means it's running in the background, number means that it's completed running, and the order of each of these matters, especially when you are linking different cells together. So it could work momentarily while you have all that information still in memory and the order technically has run the way it needs to, but if you restarted from the beginning, you might have some issues. All right. So again, I do have a notebook that I will share with you after the session, but I do want to make sure that we are kind of just going through, getting you hands-on experience with each of these things. So I'm just going to walk through a couple of items here. You've already talked about what a comment is. I went and commented this one out so that every time I run this, I don't have that pop-up that shows me all of the magic that can happen behind the scenes. We do want to go ahead and get started with string objects. It's a very basic object that in my head makes sense if I just say this is a string. Then Python's going to treat this as an object. I know we talked about object-oriented nature of things a little bit earlier. We're not going to really get into creating our own objects, but Python will create an object when we store a variable or even just create a string. So here you can do a variety of things to a string, and feel free to try these things out as we're going here. So we can print the string. If we just put it there, it's going to show us the object, but if we print it, it will also print it to the screen for us. That's one way to see the contents of any object that you dump in there, which is nice. It doesn't matter if you use single quotes or double quotes. Both are totally fine. If you wanted to print something that had an apostrophe in it, you probably want to go with a double quote so that apostrophe will show up. One other way to create a string object is with triple quotes. You can do single or double quotes there, but you can start here with triples. And then this is going to show up a formatted string, essentially. I don't want to say formatted, but it is going to be somewhat formatted. And if you skip some lines and you just want to if you want to save that indentation and spacing, you can do it with triple quotes. And then when it shows up to the screen, it has all of the space that you included inside your triple quotes. So this is how documentation blocks are often handled so that you can get some nice readable information in there about your syntax. So as an object, a string can be kind of acted upon, just like any object. And the way that we act on an object is with a method. And so there are plenty of methods that strings can use to act upon them. So if we have a string here, this is a string. And we wanted to make this entirely uppercase. We could call the upper method. And it's going to print out that string in entirely uppercase. We could change that to lower and do all lowercase. So upper and lower are both methods associated with the string. If we don't always want to be typing, this is a string, or whatever your string is, you can always save it as a variable. And so here, maybe we have a variable saved that just says, hello, Christina. If I run this, we don't get any output here. Instead, hello, Christina, the object, the string object is saved I say in this variable loosely. The variable is just saying that we have a pointer to a location on disk, or in memory, I'm sorry, pointer to a location in memory that is storing this object, and I'm naming that pointer greeting. So I have an easy access to be able to reference whatever's in that object later on. So if I say print greeting, now it's going to say hello, Christina. So this is the variable name that points to the object hello, Christina. That's a string object. So I can still say upper and lower here. I don't have to do it just on the object itself, but I can do it to the variable name as well. So there are a ton of different options. If you want help with any of those options, you have the option to type help here and greeting upper, and it'll print it right here in the screen. Remember, we also have this is true if you're in like the prompt. Earlier we opened Python in just in the terminal. You can do this totally in the terminal. If you are in a Jupyter notebook, you can also use that syntax that we talked about earlier with the question mark. And it will pop up a quick option. Just tells you that it returns a copy of the string converted to uppercase. Same thing that you get here if you use the help option. And then if you want to look at everything that you might be able to do to a string object, you can use the dir function. Dir is going to tell you a list of all of the attributes associated with the greeting object. So here again, Shift Enter just prints out a whole list of objects. all of these methods that have double underscores in front of them and behind them are kind of built-ins that you wouldn't call directly. But then if you scroll down, you can see a bunch of these that you can call directly. And that's just a very general case. If you get into some more advanced Python, there are options to for modifying and changing dunder methods, you might call them. I stumbled over dunder methods. Don't know if anybody else tries to say dunder mifflin every single time. Anyways, so you have a whole list here. You can check to see if a string is ASCII or alphanumeric or is it digit, all kinds of things. So if you're ever dealing with an object, this is a way to see what methods come with that object. We've been talking about upper and lower so far. You can strip white space from the left or right if you wanted to. Like, all of these are available for exploration with a string. So that's Python. A quick side note on Jupyter. This is a long list output to my screen that I have to scroll through. If I come over here to this space, it becomes gray for me. If I click on that, it will pop this down into a smaller, more manageable window that I can scroll inside here. And that's the case for any output that you might be getting from a given line. If I want to completely get rid of that, I think I can go to cell, go to current outputs, and clear the output so I don't have to deal with scrolling through it in the future. Questions, comments, concerns at this point? All right, we already got into variables a little bit. I didn't mention it too much, but we have greeting here was a variable. Earlier, I set a variable to A, but variables really can hold a whole variety of types of things. Here we were using an integer value. We were using strings here for greeting. And there are some rules associated with variables, though. The variable can really contain anything. It can point to anything that is an object, but a couple rules do apply. The names can be of any length, and I suggest that you take advantage of that and make them human readable so that you know what's stored in there. They can be any mixture of uppercase and lowercase letters. They can contain digits, but they can't start with a digit. So if I wanted to say store 6 kilometer shear, we could do something like this. We don't have, it can't contain, it can contain an underscore character, which is totally fine. So it could be shear 6, it could be shear 6. We probably want to spell out shear, and I realized that it's S-E-H-E-A-R. Might have some issues spelling shear, but this is you know, a nice example of all of the options that we could be naming our shear variable to. But I do suggest that you name it something descriptive of the content that you're storing, but kind of keep in mind that you may not want to name it based on the information that is stored inside it. So, you know, this is probably going to hold some float variable. So floats are numbers with decimals, essentially. And the way that we assign a value or an object to a variable is with an equal sign. So the left side is the name of the variable, and it equals whatever is on the right side. So this is assignment. There are a variety of different common data types in Python. So We could set a string, so Jane Smith. We could set an integer value, so age might be 22. We could set a GPA, for example. I just want to stop here. Can you not run a new cell until the import time cell finishes? That is true. You can only run one cell at a time. So if something's still running, you wouldn't be able to continue on to the next one until a previous cell finished. And if your next cells require the previous cell to define a variable or some data in memory, then you would need that one to finish before you can run the next one. So you wouldn't want to stop it and move on to the next. Sorry for the break there. I am hearing, like I said, some noises from GoToMeeting, and I just I do want to encourage y'all, if you have a question, unmute if I'm not picking it up right away. All right. So back to our variable types here. These are related to what I was talking about earlier with duck typing. Anytime I define something here that looks and sounds like a duck, it's a duck. And in these cases, Python will treat each of these items as the duck it looks like. So because I set name to Jane Smith, a string, it will treat it as a string. Age here is an integer. GPA is another float with the, when I say float, I mean it's a decimal point. There's also one that we haven't talked about yet, and we can set it to a Boolean variable. Notice this one turned bold green here in my cell as I typed it. True and false are both special words in Python, and they will represent a bool. So this is just a one or not one kind of option here, but pretty self-descriptive. So each of these are kind of basic ideas of the different types that we have. If you don't know what a variable is, or what type of variable is, you can always call the type function and pass it the variable that you're interested in, and it will tell you that GPA is a float and graduated is a bool. So those are both pretty useful. You can transfer these sort of to other types if you need to. Sometimes that's helpful information. If you wanted to, for some reason, determine what your GPA was as an integer, it will tell you and convert a GPA to an integer. This is not round. It takes essentially the floor of GPA and stores it in memory as one unit. So when you convert that back to a float, actually, if I stored GPA as its integer version and then I turned it back into a float, it's going to have lost all that information that it originally had in it. So notice that the first time I did this, when GPA was 3.73, and I didn't store it as another variable or overwrite the value that I had in GPA, nothing happened. So it returned the value 3, but it didn't do anything to the original value, which is nice. So GPA is still 373 in memory, and we can see that if we turn it back into a float or just print GPA again here. However, we can overwrite that as an integer, and now it quacks like a duck, and it is a duck. So let's see. Let me print that out here. It's 3. Now Python knows it as an integer. Yay. It's going to say that its type is class int. So if I turn it back into a float, now it's lost its information. And okay, so there are some gotchas there in between all of these different types and converting types. Thanks, Tim. I briefly mentioned that false is a special word along with true, and there are a bunch of special words such as if, max, true, etc. And you really should not be using those values as your variable names. So if I tried to say true equals hi, it will give you a syntax error. I've been telling you a lot of things that you can do that shouldn't give you errors, but it's also nice to understand the errors that come from doing some other things. Any reserved words will automatically turn green when typing them. That is true. So let's see, I used dir earlier. It turned green. It will happily go ahead and save variable names here automatically without complaining too much with some of these green words though. So this is going to be an issue. If I try to now say dir on my integer type so I can see what I can do to integers, it's going to say that my string type is not defined. So if you do have a word that's turning green when you're trying to assign a variable to it, so it was black, put that R on, it becomes green. You probably want to choose a different name for that. I know sometimes I just really don't want to choose a different name. And so I can put an underscore there and it turns back to black. That's one way around that particular issue, but I've totally lost the functionality to use dir in the way that we did earlier to show me all of the different methods that I have for a function. So you're overriding in your namespace the ability to do things. Another one might be print equals true. Totally lost the ability to print anything with that one. I wouldn't suggest that you try it. It tells me that a bool object is not callable. I'm going to delete these lines because I don't want them to run again, because I don't want to have lost the ability to use those two functions. So I've deleted them and I'm going to restart my kernel because I do want the ability to print things. Notice that I had that wait 10 earlier, so none of these are running yet. It's sleeping for 15 seconds. And once that finishes, everything else should run quickly. So, all right, we've gotten the use of dir and print back, but I do appreciate y'all adding those comments in there.
So what would be the point of using like that sleep?
There's occasionally some things that you want to wait to happen and check to see if given enough time, they would happen. One way that I use that is to, like when I'm locking files, I want to see if another process is using a file, and then if it is, then I want to wait until it's done. So you can sleep and essentially say, all right, in 10 seconds, has anything changed? Is there another process using the file? Maybe in 10 seconds, the conditions have changed, and I can check them again. So that's one use case. It's not something I use horribly frequently in coding though. Anybody else have a use case for sleep?
I remember making like a video by capturing individual frames that were being created, and sometimes it took a while to render. So you needed to just wait until the figure was rendered before the next loop iteration went and the next figure was produced. This is in MATLAB though, so.
Yeah, totally. I mean, sleep or wait is a pretty common utility in most languages. And yeah, it's typically, I'd say, used to see if a condition will be met with time. Given enough time, this should work. I expect it to work eventually, like something's rendering or a file may become available on disk or something about something has changed over time and you can wait for it like that with Python. Okay. So next up is doing things with these variables that we've been setting or the numbers or whatever. So we have operators and those operators generally let us do our basic math. So these are like plus, minus, multiply, and divide. So if we set some very basic variables, I'm gonna just set them here, randomly choosing numbers that popped into my head. I can add those numbers, a plus b. I don't have to just add variables though. I can add a plus 4 if I just wanted to hard code a number. And I can use any of a variety of plus, minus, divide, and multiply. So these are going to be your basic math operators. So a times b is 38. And you get the basics, very understandable things out of these four. They're going to do exactly what you want them to do in most cases. A lot of programming languages out there are tricky with divide, but Python uses a single slash to do exactly what you would think it would do in math, and is going to give you a float. Divide is always going to return a float here. And it gives you an additional operator if you want it to act like a bunch of other languages to do integer division, or Python calls it a floor divide. So if I was going to try to floor divide something, 8 divided by 3, I would need to use double slashes there, and that will give me a different response than 8 divided by 3. So floor division or integer division gets its own operator in Python. And when you use it with negative numbers, it may give you a slightly counterintuitive response. So notice if we're using positive numbers, we're going to get 2 here, but it is going to give you the floor before it applies the negative value there. So just keep in mind that that is the case. If you wanted that math to be -2, I think you would probably want to pull that value, that negative outside, and change the result of 8 floor 3 to a negative value. So just keep that one in mind. If there are projects out there where you're translating from another language, this could be an area where you might run into some different behavior. There's also modulo. Essentially, modulo is going to give you the remainder when A is divided by B. So 12 divided by 7 is going to go in there one time with 5 left over. So that's going to give you that 5. Just running through some of these basics real quick before we break for lunch. We can also do exponents, and that's going to be a double asterisk. So for 2, it doesn't matter what spaces you put in there. Although there is a PEP 8 standard that says that we shouldn't put spaces sometimes and we should other times if you're interested in the code in that way. And order of operations is still going to be applied. So if I have 2 times 4 plus 3, just like in PEMDAS in high school, we're going to get the order of operations in this expression to evaluate 2 times 4 first and then add 3. And as expected, that turns out 11. If we want to change the order of operations because of the math that we're doing, to have it do 4 plus 3 first, parentheses will do the same thing they do in math. Again, just getting that to print out to the output. A couple of these operators also work on strings. So if I say add 2 strings together, let's set, remember name is Christina. If I add these 2 together, we'll see concatenation with a plus. And sometimes it's cool to repeat strings, and you can do that pretty easily with multiply. So this is going to say if I want to write hello 3 times, then I can do that with multiply. So these are 2 of the nice ones that allow you to actually interact with something that's not actually a number and concatenate 2 strings together. Up next on the syllabus, we've gone through most of the operators. I have a couple of additional ones to introduce, and then we'll start talking about control structures and data structures and how that can start to help us build some code. So we do have quite a bit to get through in the next hour. Again, it'd be great if you could follow along with our example here that I'm sharing. And again, I will share with you after we finish up today a link to a GitHub page that has nice documented examples in Jupyter Notebook form that you can interact with. All of the more in-depth examples that maybe I skipped over. So, all right. Any questions or concerns getting started back?
Nope, I just want to make sure you remember to hit record again.
Thank you. I did actually remember to put my big Post-it on my screen. And so I got the recording going just before we came back, and I appreciate that. Okay, so we went through some of these arithmetic operators. We have a couple of additional ones though. So this allows us to do all the math that we need to do. But sometimes we want to both augment and assign values. So we can totally do that with Python in one easy step. So for instance, if I wanted to increment a value, and we'll talk about why we might want to increment a value later. We have A is 14, the last time I said it up here. So if I wanted to count by 2s, or even just add something to A at this point and reassign A, then I can do that with an augmented assignment operator. So I can say plus equals, and that is that augmented assignment 2. And then I run that. A is now going to be 16. So what? So if we reset it to 14, we'll take a look at this. Oh, keep hitting Shift Enter by default here on my keyboard. So if I say A is 14, and I want to do A equals 14 plus 2, or A plus 2, I can do that. But I've repeated A couple times here, and you know, you're adding on this side and then reassigning to A here, and that will do the exact same thing. So we get 16 again. So this is just a quick, easy one-liner that doesn't duplicate A and allows you to both increment and assign in one line of code. You can use this augmented operator with any of the operators that we had talked about already. So you just add any of them to the equal sign. So it could be a times 2, and then A is 32. So all of these work with the equal sign so that you can both do the math and reassign at the same time. All right. Next up, we have comparison operators. So the thing about comparison operators is that they are going to typically return a Boolean value, so a true or false value. And there are a set of these that include equal equal, and that means that instead of saying that we're assigning, like we used up here with name equals Christina, we are assessing whether something on the left side of equals, double equal signs, is equal to the value of something on the right side. Similarly, we could say it's not equal with the not equal operator. Less than and greater than are pretty straightforward as the arrows to the left or right, but we also could do less than or equal to and greater than or equal to. So any of these are available to us, and typically we're going to get a Boolean value. So A is less than B is false. I don't remember what A and B are. Let's see what they were. Seems like A was 32 last time I ran it, and B is 2. So you can do a whole variety of these types of things. You could put 32 is greater than 98 and see that it's false. Again, you can assess a whole variety of different greater than or equal to types of comparison operators. You might find some gotchas here, and because of the way Python stores numbers in memory, sometimes you may want to rethink how you're checking things, especially where float values are involved. So if I add two float values together, I would expect that this would come out to 3.3. And then if I check that that float value equals 3.3, then I would want it to say yes, it totally does, but it says false. And that is because if we just print out false, we can see that a float value has a significant amount of precision associated with it, and it may not always be the exact number that you think it is just because of things being stored in memory the way that they are on your platform. So this is definitely one of those Python gotchas that could sneak up and cause you some issues if you're using floating point numbers to control the flow of your program in Python. So just be aware. That's at least one of the gotchas. I'll try to throw in a couple of additional ones as we walk through things. Sometimes you might want to check a couple different conditionals for logical reasons. So you might want to check if something is within a range. So if my temperature is 27 and I want to say if temperature is between 20 and I want to check to see it's in a certain range. If I want to say it's between 20 and 30, I could say temp greater than 20 and temp less than 30 should get me there. And that'll tell me that my temperature at 27 is in that range. So there are 3 logical operators that you could use similarly to and here. So we have and, we have or, and we have not. So not can be used on its own. Earlier we were talking about strings having methods that could return a Boolean value. So let's see, dog is, and here's another thing I forgot to introduce, but if I hit tab, it will give me all of the matching auto-completed methods that I could call on a string object that start with is. So you can do that from the dot and it'll give you all of them as well. And this is a Jupyter specific thing. So if I want to check that dog, the string is numeric to see if it contains numbers, I can call that. It will return false because dog contains letters, not numbers. And then I can use not with that to change the answer. Maybe my condition that I'm checking is I want to look for the opposite of whatever this is. So if I run that again, you can see that adding the not to the front of that is going to give us the opposite of the return of this. So you could say not true, not false. Again, not is one of those that's going to show up in bold green, and as well, and I'm sure or will too. You can't assign those as variable names because they are in bold green. If we changed or here, just going back up to a previous example to show an example of or, here it's interesting to note that it's going to check the first one, and this will return true if either of these are true as the return value. But if the first one returns true, it will not assess the second one. So it never even made it to this chunk of code in this assessment of this whole expression, because knowing that temp is greater than 20 satisfied the requirement for this one to say that at least one of these is true. Just a quick note there. So those are the 3 logical operators. We have our comparison operators that can be used in conjunction with those. Any questions? Earlier we talked about transferring the different types of objects to other types. And that's another space for gotchas, especially where Boolean values are concerned. So if for some reason you wanted to assess the return of something that returns something other than true or false objects, then you might be in a little space of this is odd, you know. So in general, false is going to be associated with the number 0, and true is going to be associated with not the number 0. So a lot of times we'll only hear about that being 0 or 1, but for Python, if we transfer or retype an integer value, 0, to a Boolean value, we can do that. And we'll get false for 0, but if there is any other number in there, positive or negative, you will get true. So 0 is false, not 0 is true, even if it's negative. And let's see. Also, strings are a little bit of a gotcha here. So you can transfer the type of a string. So if you have anything in the string, it will return that this is true. It's not empty, essentially. So to get false from that, so maybe you were checking, is the string empty or is it not? You might say if not, empty. I don't want to do that right now. I just want to show you that the bool value for an empty string is false, but don't get that confused with a space in a string, because that does not count as an empty string. There is a character that is a space, so it is not an empty string. So the only thing that is false for a string is an empty one, and that can be single quotes or double quotes. I'm pretty sure you can also throw your triple quotes in there, and they're all false. And then there's a special value in Python that is the object none. Again, bold and green here in Jupyter. It's just an object. It will also evaluate to false. So if I do bool false, so any of these 0, 0.0, if you're looking at a float, will also return false. But empty strings, zeros, and none will all be false when you convert them to Boolean. This gets, I know this is very basic and a lot to kind of think about in terms of just types, but we're about to get into control structures. These are going to evaluate all of these conditional statements to do something within the workflow of your script or program. And that means that we're going to want to make sure that we're doing exactly what we think we're doing as we are evaluating whether something is true or false. So if you're evaluating a variable and it contains one of these values, you really want to know if you're checking the right thing. So it's and all of them are going to be checking the Boolean values of some expression. So is it greater than 2? Is it equal to some string that I expect? Is it a string at all? Is it empty? So those are the reasons that we do want to make sure that we understand how Python treats different values, different Boolean values especially, because everything kind of gets associated with control structures. Any questions? Okay. So I keep saying control structures, but I just want to make sure that we're on the same page there. These are blocks of code that really are just going to be there to make decisions about how your program is executing. And those can be conditionals or loops. Conditionals are going to allow you to make specific selections about which code is run, versus loops that are going to kind of iterate over the same code a bunch of times. And different loops can iterate different numbers of times based on the conditions that are met. So let's get to some examples of conditionals. And the basic example is an if statement. Nearly every programming language that you're going to run into has some notion of an if statement. And in Python, an if statement, and I'm saying if statement, just like this, is going to take the form of if condition is met. So if true, we can just say if true if we want. So if true, then do something. Notice that my cursor jumped over automatically. I did not do that. This is indicating that Jupyter knows that we have entered a block of code. Python does that by using white space to indent over. So everything that is at this level of indentation with white space is going to be run if this condition is met. So if true. Here we're saying it's always true. We're always going to run this just as an example. But if whatever expression you have here evaluates to true, run everything at this level of indentation that you have. So if I run this code, it will definitely print high. If I say if temp greater than 40, it's print warm. I can do that. Remember, we can also print temp to see what it was. It was 27. So here we can see that the conditional was not met, so it did not execute this block of code here. So this is one way to make decisions on whether or not to implement or to execute a particular block of code. And you can put a bunch of lines here if you want. You know, you could set another variable, you could do math, you could call a function, anything that you wanted to do. And then, okay, so here again, this doesn't have to be just a single line. It can be as many lines as you need inside that if statement, but they all have to be aligned at that same level of indentation to be a part of the code block that's in the conditional. Once it comes back out and is not aligned with that, that means you're outside the if statement and you're back into the regular flow of the program. So what's happening here is that it's evaluating the expression. It's deciding that the expression is false. So it skips everything in this code block and goes to the next line of code that is at the same level of indentation. There's a lot of stuff going on here. Any questions? Okay, not hearing any. We can build onto this if statement. A lot of times you have a whole list of ifs going on. So I have prepared an example here that I don't want to spend all of our time printing out, but you can absolutely get a little bit more complex with this. I'm just going to copy paste it here and show you that you can make a whole tree of decisions if you want. And the syntax for that is very similar. If temperature is greater than or equal to 80, you can print a message here and go through a whole variety of things. So in the flow of an if else statement, you can have as many else ifs as you want. You don't have to have any. You can leave all of these out and just do if and else if it's a either or situation. But if there are many options, you can use else ifs as many times as you want, really, to evaluate. The control part of the code will go through each of these successively until it finds one that returns true. So consider that when you're building longer if and else if statements, you want to make sure that you're actually falling into the right bend category here. So we have temperature is 78. If it's greater than 80, then we're going to print hot. It's hot to the screen. It's not. So this one is not going to evaluate to true. So it jumps immediately to the next else if statement to see if temperature is greater than 60. If it is, and we have it set to 78 here, we'll say print it's nice out to the screen. And then if we had set something like 55, 755 is pretty warm. 55, then it would even pass here and go down to the next one. So it will evaluate each of these in order to see when it's going to get a true return from the conditional that's met, and then execute the code in there. If this code is executed, it will do that and then jump to the next line that is outside the loop. Each of these items inside really do need to be at the same level of indentation to make sure that they work. They can have one or more items inside that will be executed. And I'm going to go ahead and execute this now. So 55 degrees out Fahrenheit. And I've said it sure is chilly. And then it executes that because it's greater than 32, but less than or equal to 60. And then jumps out of the loop because it's done all that it needs to do and prints outside the loop. I said loop here. That was probably an oversight. This is outside the if statement. We'll talk about loops in a minute, but any questions?
So for this if-else if statement, it matters on which order you're putting. It's just checking for the first true condition, right? Because technically it's greater than 22, but since it got to 32 first, it's just grabbing that one, right?
That is correct. So it does matter in this case how you're evaluating these things. So if you're doing, bins of temperature, you really want to make sure that you're setting this up the right way. If you set it up, if temperature is greater than 20 first, and then else if, no, print cold. Do you really want to print a string here? Apologies. This is why I copy pasted it here. And then else if colon, and I'll need to go and tell Jupyter to back up there, which is a bit annoying sometimes. So I can't do it in this order and get the expected result. Because here we wouldn't be able to get to the actual bin that we wanted to get to with this temperature because we're checking for 20 too early if we wanted to check for something that's in a bin higher than that and do something different. So this is going to evaluate and do the code that is associated with the first true assessment as you go down this list. So here it's going to say, even though we have it as 55, the temperature is 55, it's going to assess it as cold because it is greater than 20. I know I didn't put all of the loops in or all of the conditionals in there that we had before, but I'm hoping that kind of points out the issue that we were talking about there. So just like the augmented operators earlier, you can assign a Boolean value to a variable if you like. And I'm going to use a very contrived example here, but you can do all this just by doing a simple if statement in the assignment of a variable. So we want to set freezing to true if temperature is less than or equal to 32 Fahrenheit, right? And else it's going to be false. So you have the ability to do some very simple just if parts of this. You can't go through the whole else if range here, but you can do if and else if you want to do one thing or another, and then be able to save that value to a variable. So here freezing is then set to false. This is kind of a moot point for this example, but I did want to show you that you can do this, and there's a variety of reasons you might want to. But you don't have to go through all that syntax for this particular example. You can literally just say temperature less than or equal to 32, and that will get you the same result, because that return value for that statement is going to be true if it's less than 32. But note here that when you're doing an assignment like this with a single line conditional, it's going to evaluate this part first, the middle part. So just like it evaluated if temperature in the example above. So evaluates the middle part, and if that returns true, it gives you the first thing. And if it returns false, it gives you whatever is after the else statement. So if temperature is less than or equal to 32, do this part, else do this part. Just another shorthand that you may come across. Okay, so next up, we have another control structure. This was the conditional. Now we'll start talking about a while loop. And while loops also come up in a variety of different languages and are going to help you iterate over a block of code again as many times as the conditional that you want to evaluate is being met. So a while loop is going to look like this. While true, do something. And again, I'm using this true here to just say that we're going to do something forever, essentially. Because what happens in a while loop is that once your code gets here, it's going to assess your conditional here. So temperature less than or equal to 32, colon. While it's freezing, essentially, do something. Let's provide a quick example of how to warm it up. So let's say it's 20 degrees out. Let's say it's 25 degrees out because I don't want to burn everything to the screen. Let's warm it up by 2 degrees every time we go through this loop. We want to print temperature. I just hit tab to autocomplete, and this will allow me to see anything that started with temp in the variables that I've already defined in my notebook. And then this is a space where I would use augmented assignment to plus equals 2 degrees. I want to warm it up 2 degrees every time I go through here. So we start with 25. While temperature is greater than or equal to, less than or equal to 32, we are going to then perform any of the code in here that we need to. So each time we go through, we'll start at 25, assess that temperature is less than or equal to 32. We'll print the temperature if it is. We'll increment the temperature by 2, and then the control goes back to the while statement after that and assesses it again. If it's still true at that point, it'll do all of the things inside here, and then once it stops being true, it will then return control to the script at the same indentation level outside the block of the while statement that it's being executed in. So if I run that code, we're starting with temperature is 25. we're incrementing it by 2 in place, essentially, and then assessing it again. Next time it goes through, it's 27, and then 29, and then 31. So when it's 31, it comes in, it adds 2 to become 33, and then goes back to check again at the while statement to see if it is less than or equal to 32. This time it's changed to false, and that's the point where it stops executing the print and temperature increment, and then returns control back to the same indentation level, the same code block below the while statement, and prints done. Questions here about a while statement? Okay. So while is pretty common among a bunch of different languages, and you can essentially treat it the same as most other languages from my experience. I do appreciate that you have a break option, so you can kind of use while along with a whole variety of other things. This would kind of go back to why we would use sleep. Python specifically lets you loop over code indefinitely just by using the while true. It's always going to be true. So maybe you want some other conditional that depends on a variety of other things. You can totally just set it up to be while true print true if x equals 4 break. So this is totally a contrived example, but if x equals 0, we can do increment x plus equals 2. And so this is an example of how you might nest a conditional if statement in a while loop. There are some reasons why you might want to do that. You don't really know how many times you want to go through this thing. For example, you got to be real careful though, because you will get an infinite loop in some cases. I'll show you that in just a second. So we're incrementing by 2 from 0. I'm going to make this 8 here. So I got an invalid syntax error here. I only used 1 equal sign. That's going to indicate assignment instead of comparison. I do need to use 2 there. And then it's just going to print true. Every time it iterates through here, it can also print x here if I wanted to do that. So I'm printing true every time until it gets to 8, when it stops going through this process. It's not going to increment it again. It's just going to break and go out here outside the loop. If I run that quickly again, you'll see that it got to 8. It hit break because this evaluated to true, and then it just kept incrementing. Okay, well, what if I changed my initial condition to 1 and then ran this code again? Will it ever hit 8? And will it ever stop iterating? The answer there is no. This is an infinite loop. Notice that we have an asterisk here, and it just keeps going forever, and it will keep going forever. Notice that I can't even scroll to the bottom of this. Like, we've gotten real big real quick. We're just incrementing by 2. You need to hit the stop button in this case so that it will stop execution. It's probably a good idea to also clear your output of the cell here, so that all that's not still hanging out there. This can kind of contribute to the use of a bunch of memory in your computer and do some interesting things. My computer is whirring right away now after doing that. So just so you know, that is an option. So you want to make sure that if you're making these while loops, that you've kind of tested that your conditions can actually be met by your initial conditions and the tests that you're doing here. So just so you know, that is another reason you might want to stop the execution of this cell. So as long as we're talking about even numbers and we're incrementing for evens and we're checking for evens, everything works out fine here and it does what we expect it to do. So I introduced break here. It's also interesting to introduce continue. I'm gonna again copy paste an example that I have prepared here to save a little bit of typing time. So, and here I also have showed you a little bit of additional information with print. I'll talk about that in a second. So if we start with x is 10 and we increment as long as decrement, sorry, as long as x is greater than 0. So we're expecting to count down this time. So here I'm counting down with the negative augmented operator, counting down by 1. If x equals 6, we're going to continue. Continue is a little bit different than break. Break just put us out here to done, but continue is going to skip everything else that's below it and go back to the next iteration of the loop. So this is going to allow us to not print 6 as we're decrementing through everything. And one additional thing in this example is that I've added an argument to print so that the end is a space. The default end for print is a new line, so we get a new line for every time we call print. If I change that to something other than new line, it will put that between each of the times it prints. So in this case, I want a space, so it prints all on one line. If I run this code, you can see how that changes. I mean, I could put an X in here if I wanted to. See, this one printed outside the loop, and I put an X there instead of a space. If I put an X here as well, it's just whatever you put in there is going to be the end of the line there. Okay. I'll put another comment in here that stop execution of loop. All right. So continue is just going to continue on the iteration without doing what's below it. Break is going to exit the loop altogether and spit you out back at done, or at the next line after your while loop. Questions? All right, y'all are pretty quiet out there. Definitely pop in if you have questions or comments. If I'm missing something major, that's also a great place to pop in. Okay, so I want to stop here and talk a little bit about data structures before we get to our last control structure. And data structures can be a whole variety of things, but here we're talking about collections of items. So in Python, there are a couple of different collections, essentially. And the ones I want to talk about first are pretty simple groups of different items that we've already talked about, or different objects that we already talked about. And the first one is a list. A list can be a list of any of the objects we've talked about so far, strings, ints, bools, you name it. And you can assign that to a variable just like you have any other object so far. The cool thing is you can iterate through those. So you can start to talk about different items in the list and printing out each item and doing things with individual items inside. And lists in Python are going to be denoted with square brackets, and items in the list are separated with commas. So if we wanted an example that was just a list of strings, we could talk about fruits. And this list can have multiple entries that are the same. We can add to this list, take away, and do a variety of other listy things to it. You don't have to have string objects in there. You can also have number objects. Again, I'm showing you examples where I'm assigning these lists to a pointer, a named variable, fruits in the first case, A in the second case, because that's a super descriptive name. Or you could have a variety of different object types in a list. So here, foo is just a list of random objects. So I can put strings in there, integers, Boolean values. I can even put another list. So this is a list of lists. And then if I print each of these out, sorry, I am copy pasting here to save a little bit of time, we'll see that each of these items just comes out as we expect, but this time A is filled in here, and so references back to the list where A is saved. So it shows up as the list of lists. These are always going to show up in the same order that you declared them. With some versions of Python, I think older than 3.6, there are some structures that will not maintain their order by default. So that's something to keep in mind if you're working with older versions of Python. But lists are always going to keep their order, so you don't have to worry about that. As any other object, lists have their own set of methods that you can act on the list with. If you do fruits in dot, you will see in Jupyter that it pops up all of the options for what you can do to a list. And we'll talk about a couple of them here. Again, you can use that dir command from earlier, but it'll give you that whole list of dunder methods, along with the ones that we just saw on that list from Jupyter when we did a tab after that dot. So if we wanted to count the number of occurrences of a particular item in our fruits list, we could totally do that. How many times does orange show up? Just once, but how many times does apple show up? Twice. So we have apple at the beginning and at the end, so you can count items in the list. You can swap the direction of lists if you would like. So maybe you use the reverse method and, so in this case, this is going to return a list that is the reverse direction. Oh my goodness. That's not true. It returns none. It reverses the list in place. So if we're printing this, we can see that A is reversed. When we print it again, we see it's the opposite direction as the first time we assigned it. So it will change it in place, but it still has all of the same items in it as before. We could run this again, and it's back to the way that it was originally. So you have to be careful with list methods. You really want to be looking to see if it's going to be acting in place or if it's going to be acting to return a new list object for you. And you definitely want to make sure that you're not modifying a list that you need to use later in its original form. So you look at fruits, we can really start to, let's redefine fruits in this because I'm going to run it many times, I'm sure. If we wanted to talk about adding new things to the list in specific places, we could insert at the second location, banana again. Print fruits. Notice that this is another one that should have inserted.
I think, doesn't the index start at 0 for a list?
It does start. I was going to mention that. So 0, 1, and 2. If we insert banana at 2, I was expecting to see another banana. Oh, boo. I should probably be acting with the appropriate list. There we go. So 0, 1, and 2, we get a banana before kiwi. That's what was going wrong there. Okay. So this is another one that acts to modify your list in place. So it returns the special object none, and then you do have 0 indexing in Python for everything that has an index. So you would want to start counting from there. That can cause some issues occasionally when you're thinking through this. Some program languages start from 1, so they would say 1, 2, so they would insert banana here. Python does start from 0, so 0, 1, and 2. So it's inserting it just before kiwi. You can add things to the end of your list. So if we fruits dot append grape, and then print fruits again. We can see that we've added grape here to fruits. You can remove the same way if we wanted to remove banana. So I encourage you to go through the different methods associated with the list to see kind of how each of them behaves. And if we remove banana, it will remove the first occurrence of banana in the list, starting from the 0 point. So we've added it here, we've added grape, and then we've removed the first occurrence of banana. If we did it twice, it would remove the second. If we try to remove something that doesn't exist in the list at this point, dog, it's gonna give us an error that the thing that you're trying to remove is not in the list. So you do have to make sure to be careful with that. You can also pop the last item off the list. Sometimes this is kind of useful for a variety of different algorithms where you're adding things and removing things from the list one at a time, and it doesn't really matter which order you're going through. So if you did fruits.pop, it will return the item that it popped. If I spelled fruits right. So it returned grape because grape was the last item in the list. If we then print fruit here, notice that there is no grape in fruits anymore. Whew. Indexing is another important thing that you can do with lists. And so if I wanted to see what was in the third spot, 0, 1, 2, 3, I would hope that this would reference banana. So again, indexing can happen by number. and it's counting from 0. You can do everything after the third number by using a colon there. So it's just going to say 3 to the end, whatever that might be, and print banana and apple. You can do everything up to a given index, up to 3. And here's another Python gotcha. It's going to go up to 3. So it's not going to include the third element. It's going to stop just before that. So we shouldn't expect to see banana in this example. So that's a little bit more on the indexing. Questions, comments? All right. And just one last thing, if you wanted to change a particular banana, change a particular item to something else, say we wanted to change this list and say fruits at 3 is no longer banana, but it is indeed kiwi, we can do that as well. So now we have 2 kiwis instead of a banana and a kiwi. This does not work if you want to add an item to the list. You would need to append it. So we only have 5 items in this list, so the index 5 doesn't exist because we have 0, 1, 2, 3, and 4 here. If we try to reference 5 to say I want to add apple at the end, it's going to have a problem because it can't access that index. It doesn't exist yet. So that is the case where you would want to use append to add apple to the end of your list. Then you would have access to reference or index the 5th item in the list. There's also a good chance you're going to want to sort a list at some point. There are 2 different methods or ways to sort a list. One of them is going to do it in place. So if you use the methods version, it will do it in place. And let me again grab an example of fruits up here because I'm definitely doing some in place stuff. And so this is going to return none when I do it because it's doing everything in place. So it's printing none when I do the sort method, and then I print fruits again, and we can see that everything has been rearranged into alphabetical order. If I want to not do that in place, instead I want to return an object that is sorted, I would need to use a function sorted and pass fruits to it. And this time, if I print this and then print fruits, we'll see that print sorted is going to return a sorted list for me, and then I'll be able to print it out, versus this one that's doing it in place and returning none. And then when I print fruits later, it's the original fruits list that I started with: apple, orange, kiwi. So those are just 2 different ways to get a sorted list. And you can always check if something is in a list with another Python special word here. So you can say apple in fruits and see that it is indeed in fruits. So that could be one of the conditionals that you put. So if apple and fruits, do something with apple or not. So that's another type of thing that you could use in your conditional. All right, so now that we know more about lists, we can talk about for loops. And these are pretty straightforward. They are very similar to a while loop, except you kind of get pared down syntax, and you know in advance how many times you want to iterate through a certain set of code. If you know it once you want to iterate like 4 times, or if you have a list that you want to do something with each item in the list, a for loop is a great way to do that. So for very basic syntax there, we could say, let me just go ahead and use the fruit example. For fruit in fruits is one way that we can iterate through an existing list. So here the for loop syntax is for variable name in some iterable item. In this case, fruits is a list. There are a bunch of different iterable items in Python, but this is just an example of iterating through a list. Print fruit. So now we have the example here of referencing the variable that's set. So each time this goes through an iteration of an item in the fruits list, it's going to set that item to the variable named fruit, and you're going to be able to reference that. And in this case, it'll iterate through and come to the first item in the list, apple, assign it to the pointer or variable named fruit, and then we'll print fruit to the screen. So we should see apple come up. And then it'll go through to the next item in the list and print orange, and then kiwi and banana and so forth. So here is that code running. Again, we have the syntax for variable in iterable item, colon, come down to a code block that's indented and do some stuff. And we do that stuff as many times as we have items in the list. If we wanted to go through a certain number of items, we could also use a handy function called range. Range, again, is going to behave a little bit similarly to the indexing that we talked about earlier. It's not going to include that last item. So if we wanted to do 10 numbers, we can put 10 in here and say for all of the numbers in the range of 10, 0 to 9, we are going to print I. And that's exactly what we're doing here. This is definitely another Python gotcha, especially for newcomers, and especially for people who may have been working with other languages in the past. Range here is going to give you a nice way to just go through a bunch of numbers, integers, but it is going to always start at 0 by default, and it will not include the last number here. So if you actually wanted to iterate through the actual numbers 1 to 10, you would want to give it a couple of arguments here. So if you give it 2 arguments, you can iterate from the start to the stop. So this will tell it to start at 1 instead of 0, and then it will go all the way through 10 this time because it stops 1 before the last number. So if we take a look at that one, that's what we expected in iterating through 1 to 10. If you only wanted to do the odd numbers, you could add an increment as the third item or the third argument in range. So range is pretty versatile. You can give it 1 number and it starts at 0. You can give it 2 numbers for a start and stop, or you can give it 3 numbers for a start, stop, and increment. Negative indexing. I caught it late. That's another pretty cool thing here. We can also do that with ranges. If I did want to index fruits, we can say -1. It's in print fruits. Sorry, y'all. Oh, that was a horrible example. So I'm printing fruits as we last stored it. And then I can reference -1, and that will give me the last item in the list. I can go -2 and have it print the second to last item in the list. And if I wanted to print up to the second to last item in the list, but not including it, I can use negative there. Similarly, I could count down through through range in a similar way. So if I wanted to go 11 to 1 by decrementing the list for I in range, print I. There's kind of a correlation here between how you can index things. So negative indexing isn't available in a lot of other programming languages, and it is a pretty useful trick here, especially if you want to find out what the last item in the list is, or second to last, or whatever. So you can use negative in there when you're indexing or when you're decrementing through the list. All right. One other quick Python gotcha. If you're just if you're not sure what is contained in a variable, strings are actually iterable, and it has thrown me off several times. So if I just say for I in apple, print I, it will tell me each of the characters in the string and do something with those. So this is another area where it's a good idea to know what you're working with a little bit more clearly, just so that you can make sure that you have that information there. So we've been working a lot with lists so far. There's another collection in Python that's very similar to a list. It is called a tuple. And the difference between a tuple and a list is that once you have defined a tuple with parentheses, not square brackets, you can't change it. So you've lost all the methods that go into appending and modifying and taking things away and all that stuff. So if you have something that's really meant to be set in stone, you can totally have that available to you, and then you can't modify it. So that's one of the cool things about tuples. So here, maybe we want to set coordinates X, Y, and Z, and so we have values there for those. We don't have any of the methods that we had for lists there. We only get to act on this by counting it and index. And if I just type index and then call it, then it's not gonna do much for me. However, I can say put 32 in there, and it will tell me what the index of that particular value is inside the tuple. Another thing that you can do, which is pretty nifty and helps a lot with tuples, but not necessarily always lists, I guess, is unpacking. So one thing that you might see is that you have this coordinate value system here, and some folks might want to go and index each of these to say X, Y, and Z are each of these different items here. And now you have X, Y, and Z set as variables that you could then reference later in your code, but Python allows you to do this again in one really nice line that says X, Y, and Z are assigned to the items 0, 1, and 2 of your tuple. But yeah, tuples are totally indexed all the same ways that lists are. And yeah, that process of not being able to change it or that it's immutable is a feature of a tuple that a list does not have. And then There are also sets that are pretty similar looking, and sets have quite a few other features from lists or tuples, but they are essentially ways that you can kind of just see unique items that are in a list. You can't index them at all. Just think about it being a change purse with a whole bunch of different coins in there that only have unique coins in it. So anytime you pull one out, it's going to be the only one of that kind. You can see if two different purses have overlapping coins, or if they, all of the kinds of things that you might do in a statistics class for sets of numbers or that sort of thing, you can perform with sets. I won't get too far into that, but my example notebook will have some information about sets. If you're following along with the syllabus, we did not make it to dictionaries today, but we will definitely cover those a little bit more in our next session next week. I'm not hearing things. I do want to point you quickly to a GitHub repository that you're welcome to go to. I will put the link here in chat and share it in the Slack a little later. But I do have a Python training notebook that I have been following along with today that you are welcome to follow along with as well. You can clone this repository if you know what that means, but you don't have to. I have set it up with a binder so that you can just click launch binder. Everything will spin up right there in your browser, and you can start playing with any of these examples. If you exit this browser, none of your work will be saved, so you can totally feel free to work here on any of the examples, play around with the code I have, and get a preview to some of the things that we will be talking about next week with dictionaries and functions. So please feel free. Hopefully it loads for you a little quicker than this, but clicking that Jupyter, that launch binder button should spin up a notebook for you right there in the browser. We're starting to see my Jupyter Lab instance spin up here, but notice that it looks pretty similar to what we have been looking at all morning. You can run these the same way that you would in the instance that you might have been working with. So feel free to check that out and use it as needed as a reference. Also important to note is that you can just see the contents without it being interactive right here on GitHub if you just click on that page. So you can just use it as a reference without spinning up the binder. All right, that's all I have today.